Good afternoon again. I think it's time we can start with the second part of the, let's say, the Docling experience here at the iDev. I don't know, many of you were in the talk yesterday. Maybe you already got an idea about what we can do and the problem we can solve with Docling. Today, we really have like a workshop that we really thought about can even be like hands-on. Now, we will see how much we do hands-on, how much we do more like as a guided flow. But again, we really want to have this 1 hour that we're going to spend together a bit more as a way to show you how you can really like use Docling to really solve some of the problems you have in building GenAI applications, which is bringing documents as an input format. I'm Michele Dolfi, one of the researchers and engineers behind the Docling, and I'm here today with Cesar, my colleague. We both come from the IBM Research Lab in Zurich. So in a nutshell, and really like we have basically 3 slides, then we really go into real coding. For those of you who are not yet familiar with Docling and were not at the talk yesterday, for those that were, you have seen exactly the same slide. Docling is a package that we created from in our team. Is an open source package which is focused on converting documents. So documents, we mean PDF documents, Word, Excel, PowerPoint, HTML, Markdown, and honestly, I never remember the list of all of the documents, and even more, we really look forward to know even which formats we're not yet covering, because we want to actually drive Docling as an open community project. So if you have an idea about what is not yet supported, let's build it together. We really have a strong focus, that's also the core of our team, on understanding PDF documents. That's actually one of the core things that you will find in Docling, but also all of the other formats works very good. The output, so usually we describe Docling, and you will see that one in practice in a moment, as I'm just going, I think this could be at least a picture that describes what is going on. Docling has 2 main components. We have what we call the conversion pipeline, which is taking the input and transforming the input into the Docling document that you see there in the middle, which is basically the output of Docling, which is a structured type in Python that contains all of the information, all of the content, and the provenance information of the document. This is then basically, once you have this output, it's going to be the input of your next flow, which is making good use of the Docling document. You can go export it to Markdown, to HTML, and to many other formats, and you can build GenAI applications with this type of output, meaning maybe you want to do your reg applications, you want to do knowledge information extractions, you want to build a graph, you want to do search. These are like all type of downstream applications that we really love to see what people create out of the output of Docling. We're going to show a few today, but that's really like not an exclusive set. I mean, it's still like we can do way more, or you can do way more.
And actually, let me add that many of the demonstrations that you will see here today, they are available in our GitHub page. There's plenty of information on the section about examples. So you can feel free to experiment with them.
Actually, you gave me an idea. Something that I forgot that I wanted to show already yesterday. Let me see if I can bring it up here directly. We just released yesterday like the Docling website. So if you need to find anything about Docling, you can now go on docling.ai, and you will get to the new landing page of Docling, which is actually like an easy way to just go on the GitHub repo that I hope all of you will do to put a GitHub star, at least during or at the end of the session. And as Cesar was saying, we have like this list of examples that, that's a long list. We basically took a few ideas of those examples to build some, let's say, lab that we can do together in the workshop today. But the full, basically everything, it's available as examples, maybe even with dedicated explanation for the different topics in that case. Back for a moment here. Now, if we want to be hands-on, that's actually where you need to start taking out your laptop and follow a bit what we're doing. That's a bit the plan of the three main, let's say, topics we want to show you and to do together with you today. The first one will be an interactive session where we really like get, for the first time, convert the first document with Docling, get to use the output and actually try to tune a bit of the conversion options in Docling to even do more than what you get as a default. This will actually be a bit the beginning for being able to build nice applications. For example, something that can go in direction of chunking documents, multimodalities, multimodal array that we have in the second part. And then last but not least, so we need to keep a good amount of time for the last part. It's also going to be agentic AI and using Docling, for example, as an MCP tool and to build nice agentic AI applications around it. You already seen we have a QR code which is exactly pointing you to this short link, which is then automatically pointing you to the Docling workshops GitHub repo, where you find all of the basically like the guidance of what we're going to show you next. So if you want to follow with your laptops and try out on your own, or maybe with your own documents, that's basically the place to start. I hope it's going to work now. Switching to the code. I mean,
and if anyone is following with a computer and encounters an issue, whatever, since we are two, just raise your hand and we can try to have a look.
Indeed. That's basically like a folder that the link it's pointing to. We have this README, and then we have like this, a few of these lab. The first one, so we also put quite some context. So now we're going to go through together, but you can also just repeat on your own afterwards when you're back in the hotel or before at the airport before leaving. You know what is actually the good things about Docling? You can really run everything locally. Just make sure you download the models before, but you could go fully into airline mode, and then you can do all of that completely locally on your machine. So let's actually get started. We have some text, but basically like what I want to show you is, let's see, the kernel is running, so I should be able to actually just run the interactively with you the piece of code. Is it big enough? Do you also see on the back? Good. I was told that it's good to switch into bright mode for high construct and being able to show it, so I hope that is also fine. So these are just a few standard imports. You see, like, actually you will see this is the key object. That's really the document converter object that is going to do all of the work in Docling. Just importing those. And we're going to take a test document that by chance is the Docling technical report. And really, what you see in these basically 2-3 lines is everything you need to put Docling into your code. You import document converter, the converter.convert, and this is everything you need to have a PDF document being converted to the doc, which is what you find in the results.document there. Let's see. This should be done in a moment. Demo effect as usual. Yeah. So it finished, and now we are really like, we can work with this doc object. And as you see, that this is a type of Docling document. So every time we're like having on the slides, what the heck is this Docling document? Now we have it. It's a real object. One of the examples is to call the export to Markdown, but you see like, by the beauty of autocomplete, I can quickly show you, like, you can quickly go to HTML output, only pure text, dictionary. It's like a Python dictionary you get in the end. DOCX is actually the format that we use in the small VLM models. And these are different options you can see in there. One interesting part, for example, if I do, I think the interesting one is also in save. So export will just give you the output in a variable. Save will save a file, as you can imagine. But here we actually start to have this attribute image mode that by default is placeholder. So what we can actually do with Docling is when we have more complex components in the document itself, like figures, in this case the images and the figures in the document, we can decide how we want them to be exported in the specific in Markdown. Placeholder, it will just put a comment like, here is an image, that's it. But you can choose embedded, that will put the full base64 encoded image in your Markdown, which is very nice. You can actually render it. It's all like self-contained as a single package. But watch out, then your Markdown will become 10 megabytes of data because you have all of the images in there. But this is like one way you can customize what is going on there. What is also interesting to look into the document is other attributes. For example, we have here the pages. So if we want to know how many pages, we can just count them. Tables and pictures are like all segmented into their own sub-list, so to say. And one of the key elements, you see like here the output was, I mean, I can actually run it. You see we have 8 pages, 1 table, 6 figures, and this is one of the key functions if you really want to start working with this data structure. Iterate items is the function which returns an iterator that goes through all of the elements that you have in your document. And it is just a linear function, so even if you have hierarchies, you just get a linear iterator through all of the contents. By hierarchy, we mean, for example, like a sections that maybe has a list that maybe inside the bullet list you have a sub-list. So all of these complex components can really create deep hierarchies in a document. Okay, this we already seen, like export with the HTML, dictionary, and so on and so forth, with the different components. So maybe I just had to click further and then you would see the options. Now we get into going a bit deeper into tables and in a moment also figures. So now we are taking another examples document, so let's actually launch it. And while it's converting, let me describe what we do in the next piece of code. In this case, we iterate through the tables, and we have a convenience function inside the table object, which is returning us a Pandas data frame. So once we want to imagine like we have a paper with some numeric data, we can get all of the tables out, take them into a standard data frames, and then honestly, it's just open to your imagination. In this case, we only use the data frames library to convert the table, for example, to a CSV, to an HTML. This is what we do in the blocks that I lost. This went too fast. Module object is not callable. Why? I know what is going on. I think I have a broken import. Where have we imported display? You were just running the example before, right? That's correct. Anyway, what this was just supposed to show is like to show the table, but where are we importing display now? I think I... Let me make sure that's imported before, and then we can move on. Here we go. So good. Now we just basically show the other part. Let's anyway move to the figures. That honestly, it's the one that I like more. It's even more interesting. What we do now here is now actually we do something different. Before we were just converting using the standard document conversion options in Docling. Next, you see that we don't initialize the document converter as a simple object, but we provide these options. So for each document type that we support, being PDF, images, and so on and so forth, we can specify different type of options. In the specific, in this case, we can choose what is the resolution of the images that we want to include in the final output, and we specify that we want to have both the bitmap representation of the images and something which can be very convenient, it's a picture of the full page. This is going to be convenient in the future if you want, for example, to then crop some component or to visualize the page. That's why we have these possible options. And this will always be your go-to place every time you want to change how Docling is converting document. You see, like just showing here from the doc strings, just what are a bit of the options. You can choose the image scale is what we are doing now. You can choose whether you want to activate or not the table structure, if you want to activate or not OCR, and these are the different enrichment options that we're going to use in a moment. You see, by default, they are disabled, and I guess just in the step down, we will enable them. Yeah, that's really like, that's usually also what I do all the time. I just like look into the doc string to find how did we call that option, because I will never remember it in general. The documentation page is also useful, but sometimes just a doc string is enough. What we do next is, you see, like we convert with these options. Now, given that the import didn't work before, I'm just going to use the previous output. Just apologize for not doing it fully live, but the output is done just this morning. In this case, we now go through that's what I was saying, we activated the export of the page images. So if we iterate through the page objects, we can actually save one image per page, which is also what I have here in the output. We have images, page to page. So these are like all of the images that have been generated by the code before. And this is the case where we actually ask the code. So again, we use these iterate item functions, and then we have these two if statements, one for the table item and the other one for the picture item. That's really like how you iterate through the document, and you can do specific operations for different types. So you can imagine we have the text item, which is just a generic text component, and then we have table item and picture item that have a more richer information. For example, the table item has the full 2D grid of the table, has the method export to Markdown, to data frame, and the picture item has the bitmap, basically like the binary representation of the image. What we, that's printing, so I don't need to show you, no, actually that's what I can show, okay. What this block is actually showing you, that's a piece of code which is repeating the example of getting the image. And in this case, we print just all of the images with the captions that they have in the document. So now you see like picture one, and we can see the caption that has been linked to the picture during the conversions. Additionally, we can also print all of the text, all of the piece of text that was either captured in the image, because you can imagine it could be a vector graphic images which is embedded into the document, so all of this text really exists in the document, or the OCR component actually like was able to detect these pieces of text on the image there. So that's what you see here, all of the output of this, for each picture, the caption and the text. But now we want to do something more. We want to do, that's just a visualization, I will leave it out for the moment. You can just run it on your own. What I want to show you now is the picture of classifying and describing pictures. Again, as we did before, we modify our pipeline options. And now here comes like a pretty powerful option in Docling. We have these picture description options that we populate with this class, which allows to run basically any models you can find on transformers that can do image to text. In this case, we use the Granite Vision model with this prompt that you see here. And what we get as an output is for each image, we have now a textual description which describe, that use the model to actually describe the figures. Now, I'm going quickly through that one because I wanted to show you like another difference and then show you the good output that we get out of the second iteration. Before, I was using a class that is called picture description VLM options, which is what I said, it's actually running the model locally. What we can do is also to call an API service. We can actually use an inference server where we have hosted vision language models. In this case, I use Olama locally on my machine. But if you want to call, the OpenAI API, if you want to call your Bedrock service or something else, you can just specify the API and the parameters to call it. So in this case, during the conversion, Docling will actually send the images to the inference server to be described, and then the output is included in the conversion output. And you see, in this case, we really get like a verbose description because the prompt was actually saying like, give a detailed description. That's what we get as expected. And we will really exploit in the next steps of the tutorial. So I think it's lab 3, if I'm not mistaken. We're going to we're going to leverage all of this text to really build a multimodal RAG applications, because this is all a text that we can encode using our usual sentence encoders and build a multimodal applications with that one. So this is all for this initial, the first session. That was really supposed to show you a bit like in a glimpse that in Docling, and I'm actually bringing up in a moment just the architecture slide we showed before, yesterday as well, where we showed the pipeline, which converts the document, gets into a Docling document, and then allows to navigate, to explore, to export the output into different formats. And what we did with these pipeline options was really like customizing how the yellow blocks are running in this case. There was a question?
Yeah, I was wondering because so far small Docling has not been used.
So far, I didn't show small Docling. It's actually the last block I skipped in the notebook. If we want to use small Docling, this would be what we have in the last part of the notebooks that you can run. The difference is instead of saying we use format options and then we provide just the PDF options, we need to change the pipeline. So we need to say that the pipeline needs to be the VLM pipeline. And then we are going to use the small Docling model, which can do all of the conversions in one shot. That's how you can run it from the SDK, or you can just run it from the CLI if you use the option -- pipeline equals VLM. Since you ask for the VLM pipeline, like quickly showing you like what we have as an example in the repository, this would really be the documentation how you can activate the VLM pipeline, which is, it's one-to-one what I showed you in the notebook before, but that could be a good reference point where to start from. Okay, Cesar, you have lab 2 on your side, right?
Right.
Numbers, we have, now I would have to open it up. We have the numbers in the technical report of Docling. You can see some reference numbers that we did when with the publications. I don't know if it is this one or the other paper. I think it's the other one. So in general, I think we were usually accounting for all of the steps in the pipelines. So for the full pipeline that has all of the features, around 0.7 seconds per page. So, and then you can integrate out for the full 5,000 pages. What we try to do to make sure in Docling that you can actually process long documents, so we really try to put lots of emphasis on being able to not blow up the memory that you need. So we don't want to have that, the bigger the document, the more is the memory you need to run, because nobody wants to have like 40 gigabytes of memory because it has a 5,000 documents, 5,000 pages document. So we actually, like the way Docling is working, it's processing batches of pages. You can change the batch size, and the bigger the batch size, the faster it will be, but then all of those pages will actually be in the single chunk in memory. So that's a bit like what you need to balance out. You can be faster if you can give more memory and also more compute power to the system. We're also working on, for example, the possibility of doing also the different page batches in parallel that would allow, for example, to distribute different batches of pages and then merging them together into the final document. So these are like the steps we're trying to do to really improve also the runtime for long documents. I don't know if it goes a bit in the direction you were asking. I mean, this is the point of what we are trying to do, that we can actually do different batches of pages, basically distributing them in parallel. Then you can actually see the partial results of the pages. If you want the full document together, then this needs to be merged with the library that can merge the Docling document pages together. Good?
Good. Okay, so let's quickly deep dive in the lab number 2. Why this lab about chunking? Because that's a question that we get very often. Main application of Docling when converting PDF documents or other documents is to be able to extract the text, chunking, and then embed the text and enable RAG applications. So we get frequent questions about how to build better chunks because the layout of PDF documents, it can be very rich, very complex. So we thought that could be useful to go through this enhanced chunking with Docling. There's some information in this notebook that maybe you can check on your own, a lot of background that many of you already know, but just feel free to go through. Just some few points. Chunking is one of the steps when you want to run a RAG pipeline, and it's about breaking down the documents into pieces that have some semantic meaning. We are using Docling to convert PDF documents. That means that we are creating the Docling document, structured document where we preserve the different layout of the document and also some hierarchy. So we want to exploit the hierarchical structure of the Docling document. That's why we are proposing some methods that, in the chunking theory, are defined as document-based chunking. So, we know chunking is critical because, if you are trying to embed text, you may encounter some limits in terms of the number of tokens. Also, you need to balance precision and recall in the retrieval. If you have a very small chunks, maybe you're going to be more precise in the retrieval. On the other side, having large chunks can provide you better context for the answer generation. Semantic coherence is very important, as I said. You may not want to cut the text in the middle of an important sentence, and also some things into consideration, the cost and the performance of having more or less chunks. Finally, in terms of the user experience, because if you want to retrieve the support of your generated answer, you may want to have more or less precise support context. Chunking is important. There can be, as I said before, if you have this sentence, the company's revenue increased by 25% in Q3, you're applying some fixed length chunking, then you may cut the sentence, and then you are going to have probably issues in the generation part. So the good chunking is the one that is semantically aware of the text. Let's go with some practical examples. So first of all, we're going to install all the necessary dependencies. We can go through with this, and we'll let me restart.
Cesar, maybe it's better to just show the output.
Yeah.
Otherwise, we don't move on with the next.
So, okay, we'll let it run. And basically, we have one document. This is an annual report. We'll skip how we convert the document, and the Docling document, it will give us all this structure. Just to show you as well, we have some functions as to analyze the different distribution of the chunks. And now, maybe the important part here, the hierarchical chunker, and the next chunker that we'll see later on. This one is basically a document-based chunker that takes into account the structure of the document. So if we see a paragraph, it will create a chunk. If we see then a list, it will put it in a chunk. Then if we explore the distribution of the chunks, then we may see that we're creating a lot of very small chunks. And we eventually may find chunks that are very big. Imagine a very big paragraph. In that case, that can create some issues. That's why then we also propose in Docling the hybrid chunker. This is basically based on the hierarchical chunker, but then in Docling we apply algorithms to increase the size of the chunk if it makes semantic sense, and also cut it to if we are generating too big chunks. I would let you go through through the code here, but as a result, then we find not so many small chunks, and then as well we make sure that the maximum chunk size is within the limit of the model, the embedding model. Just also as a final remark as well, we can also create or set further conditions if we want a very specific maximum size of the chunks, and then achieve these results. Finally, another final remark about the contextualization, because For retrieval, it may be important to have some context of certain chunks. For instance, if we have a paragraph, we may want to attach the heading, the header of the section, so that we can have a better recall when we retrieve the chunks, because we know that this paragraph is in the context of that section. So that's what the contextualization does in the Docling chunker. Yeah, then you can find here some examples. So let's move on now with multimodality.
I will just be brief and actually show you how you take now what we have been talking in these two examples now. So how to tune and change all of the configuration options of Docling, and how to leverage the chunking to do what? To build a multimodal web applications with an actual interesting addition that we want to show is for example, how to do what we usually call visual grounding. So you want to be able to provide to your user the information about, I was able to answer the questions because I found information here in this place of the document. So very briefly, this is something that you've seen This is something that you have seen before. It's how we can enable pipeline options in Docling. In this case, we want to activate a picture description, we want to call a model, and we want to generate eventually the output with the images. This is the document, and after the conversion, we get to the final output that we have 20 pages, 2 tables, and 54 images in this case included. I actually use I forgot to show an interesting parameter. This is the picture area threshold. So we have an option. You can imagine that doing a call to a vision language models for every little small image you have in your document might be a bit too expensive. You imagine you have a little logo in the footer or in the header. That's maybe it's useless to call a model in that case. So we have this parameter that allows to choose what is the percentage of the size of the page that your image should be. Like in this case, I think it's 10%. So we try to avoid all of the little images to only focus on the bigger images that should be the one that contain information. What we do next, it's actually working with a chunker. We actually use an extra component of the chunker, which is changing the way we serialize tables. Actually, we could do it with any type of document components that we have in Docling. In this case, we choose that when we get into a table, we will actually use the Markdown serializer. By default, we have another type of serialization, which is more like a flow of text that has what we call the triplet, name of the column, comma, name of the row equal to the number that you might have in the table. But in this case, we want to go with the Markdown. So that's a way that when we call the chunker here, we can specify, so it's a hybrid chunker, so it needs the embedding tokenizer. And then we can specify serializers. In this case, we're just going through and serializing the output, and we create, in this case, document is not a Docling document, it's a LangChain document, because we're using LangChain to build the reg application. And in the end, we get 67 text-only chunks, 5 table chunk, which is the same number as before, and 23 picture chunks. We have a print function which is actually showing a bit how these chunks look like. The important part is we have an identifier, we have the text of the chunk, that's clear, and additionally we have references which are the identifiers inside the Docling document of which text item in this case are combined together to build this chunk. That's another text chunk, but if I go further, you will see we have the image with the picture description that we did already in the previous example, and so on and so forth. I think we should actually only print 3 of those. So what happens next? That's the visualization example. We populate the vector DB. I mean, in this case, we use a Milvus store. Again, just using the LangChain reg example. This is the, where is the ingest? I think here we're already querying. Sorry, I skipped a bit too fast. I mean, add documents. So that's basically like everything which is needed to add these chunks into the vector DB. And now here comes the interesting part. So we have a questions on this document, which is how much was spent on food production relative to the amount of food distributed. What we point here are different type of chunks that the retrieval found to be relevant. So in this case, we have a combination of text element and visual elements that were found to be interesting. Let me see, where is the output? Yeah, that's where we asked the question. So we see that one, the first question basically like was answering, found that this image, so you see like the red box in this case is because we're able to know from the retrieval, we found an image that was embedded as text, and we're able to take the location of it in the full page, and that's why we can visualize it to the end user. We also have blue components that are like pieces of text, and all of this information is basically being merged together in a context in the LLM to generate the final answer of the reg applications. So that's just in a nutshell how you can use Docling with the enhanced features of Lewin picture enrichment and visual grounding to build a reg application that can look for content also inside using multimodality, so finding content also inside pictures, tables, and other complex objects. And every time the retrieval is done, you can ground the answer exactly to where it's coming from in the document. Yes? Cesar, you want to get ready in the meantime? Yes?
Do you write or build a framework for the chunking?
You mean within the Docling document? So in Docling, we have this chunker that is like a bit more like it can be extended. So we have a base chunker that as we showed before, we have the hierarchical chunker, we have the hybrid chunker, and we're actually just, I mean, we're looking for other contribution to have other type of chunkers. Usually we look for chunkers that can show that leveraging the document information makes a difference. So maybe like, well, maybe even a semantic chunker could be interesting, something that is using like the embedding in that case.
Yeah, so that's more what I'm thinking about. So let's say you would chunk for a specific industry. So you could have a semantic framework or chunking for a way to have the visual grounding, have industry-specific information before it starts making the chunk.
Yes. I mean, that's actually the two things you can do. You can change the chunker, so actually how elements are split or merged together. And then you can change the serialization or the contextualization, which is the component that produces the final text that goes into the vector eventually. So what, for example, we do in the hierarchical chunker, we always augment the piece of text with metadata information about, for example, in which section it is, like we actually include the hierarchy of all of the sections of the document. So you can actually play with those concepts that you have in documents that usually you don't have.
Okay, is that in the documentation as well?
Yes, in the documentation you find it. I mean, we have when it's in documentation inside concept, you have the full part about serialization and chunking. And in examples, we have a few here that are like serialization, hybrid chunking, and advanced chunking serialization. Good. What time is it? Okay. Another question? Okay, then I think we can move to the last example that we have for you today. In this case, we really like switch a bit gears, and we go to agentic.
Okay, so this is the last lab that we planned for today. And we wanted to show you some application of Docling in agentic AI. And also we wanted to show you how we can integrate with different frameworks. We show some of them. There could be others. We'll show some applications that could run with different frameworks, but just this is an illustration. So what we have considered here is basically, okay, of course we have Docling, and we will show an implementation of the MCP protocol because we have built in Docling a Docling MCP server. And we will also use a couple of frameworks, Llama Stack. This is an open source popular framework for building generative AI applications. And we will also use Pydantic AI for another use case for information extraction. And finally, also LM Studio as an MCP host, so as a UI application. Okay, so here you'll find information about how to install the different components. Maybe I'll stop here on the Docling MCP server because you can simply install it. And also, we have created this kind of profiles. Docling MCP supports capabilities that we have seen of Docling for conversion. Also generation. You can generate new documents with the input given by the LLM. And also, we have extensions. We have tools that leverage some internal capabilities of frameworks, and here we'll show Llama Stack with a RAG application. And as I said, Llama Studio to have as well demonstration of how we can access through a UI. And yeah, as you see in our documentation of Docling, with a single click, you can get LM Studio configured. And also, we can then set up or install the MCP server, Docling MCP server, that we run locally. Since here we have defined some profiles, that's why we run it locally, and then we set up LM Studio to use that that server. Then here I open LM Studio, the UI, and we can see the Docling tools that we have selected about the conversion, about adding titles, sections, lists, etc. And yeah, I mean, you can simply convert the document on here and then get the execution of the tools running. So you can play with that. And now let's go back to the notebook. So here I put some examples that, well, if you came to the presentation yesterday, we show also a little bit. Now, how to integrate Docling MCP to a framework? In that case, Llama Stack. So Llama Stack has some distributions, and here we show you how to install them with Podman or Docker, and then how we register different models that we have downloaded in LM Studio. Maybe I forgot to mention that we use Element Studio as a MCP host, but also because it's a framework that lets you run models locally. So that you can test that it works with some example. So now there are some modules that we can use just to show some displays. I will jump this section. And then we can connect to the Llama Stack server. And we can set up some parameters for the LLM. And just here to show a verification of that the tools from Docling MCP have been registered into Llama Stack. Here also, I highlight the one that we have requested, the RAG, because Llama Studio has some RAG built-in functionalities that we are leveraging here. As an example of integration. Now, what we're going to do with RAG and Llama Studio. So we leverage the Docling conversion capabilities and also the chunk and ingest and ingestion using the Llama Stack vector DB capability, and also the built-in search from Llama Stack, and giving a prompt. Then we can first, of course, we can create the agent, where then we instruct to use the tools from Docling about conversion and insertion. And then, as I said, the built-in functionalities for RAG from Llama Stack. And now here it comes a prompt that I was mentioning. So we want to convert a PDF document, ingest it, and then answer a question, for instance, how many pages are manually annotated in the data set described in this document. That, of course, is a document of Docling technical report. And then we can see how the different inference and reasoning steps progress, where we call our tool to convert. We get the document key. Then we insert the document into the database. That triggers, of course, the chunking. And then we have the ingestion and answering the question about the number of pages that we annotated. Okay.
This is just one comment, because one thing that we actually are doing here is not just MCP, it's actually full agentic AI applications, which is actually not doing the standard RAG. So it's not just answering the questions by taking the user input. By doing agentic RAG, we actually ask the model in the flow, in the agentic flow, a bit more, actually it happens automatically, we don't have to do much about it, to come up with how to query the document in DirectDB, which I really believe it's really one of the big steps that agentic AI and agentic RAG is improving, allows to improve the quality of building RAG applications, because you don't have to anymore make sure that your embedding and your retrieval, it's focused for how the user is going to ask the questions, because you really have a model in between which is going to interpret the question of the user and ask it in the best way possible for the retrieval step in the VectorDB. And that's basically the agentic RAG example.
Correct. We have a second and last example of a different use case using another framework. And here we're going to build agents with Pedantic AI for use case of information extraction. Let me show you the original document. These are some product specifications in a PDF document. And then, well, in this document, yeah, you have all the characteristics of processor, memory, and so on. So it's a common use case to get some instruction information from the PDF file and yeah, have some kind of key value report of the characteristics in the document about the product. So basically, here what we're doing, sorry, this one. So we're using Pedantic AI, and basically the interesting point that why we're using this is because we can define the schema of the extraction through Pedantic models, where we define exactly the structure of and the description of what we want, and then the agent will understand these descriptions and return the extracted values according to this structure. So as an example here, we say convert this document and use a Markdown representation and extract the hardware specifications of this product card. So here, basically, then what we're doing is calling the conversion of Docling. So the model will understand that it needs to do certain steps. So converting the document. And then it will, then maybe okay. Then it will export into Markdown, into text, that will provide this Markdown structure of the Docling document. And finally, it's about leveraging the capabilities of Pedantic AI and extract that information that we requested here in a structured manner. And that's what we are getting here. And yeah, that's basically these couple of examples that we wanted to show about integration of Docling by creating agents and leveraging the capabilities of the frameworks.
I mean, maybe the last few minutes, like taking maybe a few questions, but maybe like also opening it up. I mean, you've seen a few examples from doing just conversion, building reg applications, building like flows with agentic AI and MCP tools. Does this resonate with what the type of use cases that you are working on? It's something that you think you would actually like you would jump on? Maybe somebody wants to describe a bit what you think you will build next using Docling.
I still have a question about the last section.
Yeah.
So, how would you integrate the LM Studios in, for example, a front-end type of development application or a mobile application, so you can run the Pedantic agent to convert documents, let's say I want us to copy to a client who has got documents.
So you want to have a mobile application that can use agents?
Yes, no, the Pedantic one specifically, too, so you can run the Docling on a database with documents for your service.
So so basically, like use case you're bringing up is like on doing information extractions using, for example, a framework like Pedantic AI that can leverage Docling inside to populate a database of results, or?
Yes, because if now, let's say, static documents and I want it to be, let's say, default in Markdown.
Yeah. Yeah, I mean, this is like a solution you can do, like, I would say, like, if your target is eventually like mobile users, you can either populate the content of, let's say, not on the mobile device and then port on it, or you're basically like asking how you could basically do the parsing on the document, on the mobile.
No, not the parsing, for example, but make a build application that's mobile-based or web-based.
Yeah, so I think it's, at that point, I would say, I mean, what you want to do, I would say, is start to go a bit outside of the scope of Docling, but a quick answer would actually be like, all of these are frameworks. I mean, we're describing also like a set of agentic AI frameworks, and many of those also have clients that you can consume, for example, in either in Swift, in Docling, or in other languages that you can use to develop mobile applications or like web applications.
Because it's a MCP, right? So I could frame it to maybe.
That's the point. I mean, the Docling components are really like exposed as MCP tools that are basically exposed via, in this case, we actually use this streamable HTTP protocol or transfer protocol. So you just need to make sure that your agent client can call the tool that you can host somewhere. And then with your agent SDK that you can run local on your mobile, you're just going to interact with that.
Yeah, so my question was specifically because you already have a setup in LM Studio, right?
I mean, LM Studio, you need to talk to the people of LM Studio if you want to run it locally. I mean, I'm not an expert on
It's not something I can do this version of by myself.
on the mobile.
No, just the agent.
I mean, all of the examples we've shown, you can just run locally just as is. I mean, we put the link, do you have the link somewhere, the slides? Maybe that could be good to leave there that people can take in PowerPoint we have it. Maybe like switching to another like example use case that people wanted to bring up, we can follow up afterwards.
Everything was very interesting. A use case that many use cases that I have are related to this, but then what's going on is that when I extract information with Docling, the customer needs to place such information. For example, let's take the data sheet.
Yeah.
Okay.
Yeah.
Then the customer would like to take some information extracted and place those information
Into some database, right? Into some.
in something like in ERP, CRM, whatever.
Yes.
So it would be extremely useful for each field that we are going to extract with Docling to have a confidence level of the extracted data. Because in case of, it may be 99.999%. Okay, but when it missed,
You want to be able to trace it back and to understand where it's coming from. So I would say, I mean, that's a good point you're bringing up to have like a confidence of the extractions, and actually I would even augment it to say like the provenance of the extractions. I mean, imagine you have these documents of maybe 100 pages, you actually at least to know from which page. Maybe not exactly the paragraph or the table, but at least the page number where this is coming from. Yeah,
so
that's.
to put the human in the loop. Okay.
Yeah, for correcting usually.
Just my
Good. We are already,
have
maybe
last
one last
question.
question because I think we need to leave the room for the next session because I think we're in the middle of the coffee break. Yes?
I got another scenario. So, like in the example from that, you need to process a lot of documents and also not too big of budgets. They come into the restraint of you're using heavy LLMs or VLMs behind Docling. What is the minimum model you need behind it for accurate results? Because I've used a lot of document parsers, and simply said, most are shit. Most are shit. That's
So, so you're asking about basically the requirements to be able to run Docling and still get a good performance out, right?
Just that you want to have all the documents, you want to process them very quickly, because now I saw it takes 20 seconds. From what needs to be done to bring it down, for example, to 5 seconds?
So what you, let me actually bring up quickly the Docling technical report. That I anyway advise in case to, no, not this one, where is the real one? Looking for the one of that we presented at AAA. This one here. Okay, got it. So what we have here is a bit of a breakdown of the the time it takes for all of the components. So if you want to actually take down the processing time, step 1 would actually be, if you don't need OCR, turn off OCR. Actually, inside the Docling pipeline, OCR is really just actually a third-party component that actually you can swap with whatever other tool we want. It's really like a plug-and-place mechanism that we have. But this is really like taking eventually the bulk of the time in general. The bare minimum that we would suggest to really be able to get a good quality of the output is the parsing and the layout model. This will make sure that you have the proper reading order, the proper continuation of text, and so on and so forth. It will not do the table structure. So if you want the tables, the content, I mean the 2D grid, you need to have the table model also enabled. But these are like the actual, let's say, optimization flags you can use to reduce the runtime. The bare minimum would be the parsing and the layout.
Yeah, or maybe I'll see it now is, for example, at the first step, you parse it simply with only PDF parse and layout. And then have a step afterwards that the text from, hey, is there still something not parsed because it's a scanned image or it's a table? And then run it again with...
Exactly, you could actually understand. Actually, by default, we have an option that OCR is actually not running all the time, but only if it detects bitmaps in the content. But you know, by default, it will also run, for example, if you have a chart, it will run OCR on it that maybe you don't need. You just want to have the bitmap in that case, right? But in case it's the full page, which is a single image, a bitmap, then that it's the case where you want to have the text which is in there. Otherwise, you get just an empty output.
Right.
Yeah. Okay, so that was our Docling's workshop session. We have to admit that in general, we actually thought we would be running an interactive session, and then we realized that in this type of setup, basically nobody would be there checking on the laptop, so we had to flip it a bit last minute, but I hope you could at least see a bit of the examples. And really, like, we tried to make all of them available, so you can run them on your own. Feel free to reach out over, in all of the possible way you can reach out to us, connect with us either directly via LinkedIn or so, write in the GitHub repositories. We have discussions, issues. Usually we're pretty active in responding to everybody. Thanks.